Okay. Hi everyone. We're just going to see that everything's working. Yeah, okay. Well, I'm still seeing offline, but oh yeah, here we are. Don't know why I'm not. Oh, here we go. Chat. Okay, let's see the chat, but not myself. That's good. Hi everyone. I'm Saar from Boldport, and today I'm going to assemble the next kit, which is the Cordwood Puzzle 3. And yeah, we'll see how it goes. It's a hard one. One of the reasons that I'm doing this, other than helping people out, is to check out the infographic with the assembly information and instructions that I've created for this. And so I'll go through these steps and check that everything's there. All right. So right. So this is the kit as club members are going to get, and this is what it's going to look like at the very end. This is a third of the Cordwood puzzles, hence Cordwood Puzzle 3. It has 3 identical PCBs that are arranged in a particular way to create this circuit. The first one from 2 years ago was this Cordwood puzzle, and the second one from a year ago was this one. And these are still available on the club, at the club shop. So if you're a member, you can get those, and there's a discount code for 20% off of these. At the moment, I can't remember what it is, but look at your email or on Twitter. And this is a prototype, the prototype version of it. So the idea behind this Cordwood puzzle came about by looking at things, how circuits were constructed in the past, and I found out about this Cordwood construction technique, where in order to save space, engineers put components in between 2 PCBs, and those were particularly useful for going into tubes. You know, round PCBs, components in between, and then put into tubes. So that's why sort of the genesis of this this first one, and now it's sort of a tradition with the club. One of the things that I try to maintain with those Cordwood puzzles is that the circuit board is identical. And in order to create these circuits, you have to sort of do some mental gymnastics to figure out how to make that happen. So I wanted to show a couple of things that I've done as I was doing these this last one. So I printed out some concepts, and you see, you'll say top 3, oh, they're mixed up. Anyway, they're 3 per batch, and the first couple of times it didn't quite work, and I had to change an arrangement of the LEDs in order to make that work. And part of the exercise was to draw it on the whiteboard and figure out how to connect things, and this is easy because you can just delete it. So I got there at the end. The circuit itself is the same as the others, the sort of the main component of it. The circuitry is identical, it's just the arrangement is different. And to the infographic, the infographic is split into sort of three parts. Not, yeah. If you don't want to have any help, you can look at the components that you get and figure out how to build it. If you want some help, well, you do that by tracing the PCBs, right, and sort of reverse engineering it. If you want some help, you'd use this section here, where the circuit diagram is sort of laid out, and you can see the top and bottom tracks and figure out what's going on here. If you need a little bit more help, you move on to these photos, where visually you can figure out how to construct the project. And finally, this area, there is instructions basically on how each component goes in, plus sort of augmented by these images and instructions, or rather sort of a recipe in the sense that you part of the whole deal is that you need to figure out how to do it in the right order, just like a puzzle. So this gives you that, and then a description of the circuit itself, and then the how to use it. So I'm gonna put this thing here. So before we begin, we're gonna solder some. We're gonna do some soldering. I have downstairs at the workshop. We have an extractor fan and filter, and but it would be too loud and too cumbersome to use here. So I got this USB fan. It has two fans in there, and I put a filter, carbon filter here, and turn this on, and then it will suck the air. So I'm using it in the reverse way it's meant to do. It's meant to be used, and hopefully it's not going to make that much noise. The other thing is, the components in here are ESD sensitive. That means that if you're charged and you discharge on them, they might get damaged, and you wouldn't know until it's not working, because there's no visible marker or visible. You can't see that it's damaged. So what I'm going to do, so it doesn't interfere, I have a ESD wristband here, which I'm going to put around my leg. So take my shoes off and just put it around my leg, and then it's not going to be in the shot, but I'm properly earthed. Alright, so solder safely and ground yourself. That minimizes the chances of things going wrong. Alright. So we have the PCBs here, and an anti-static bag with the components. Okay, first thing I want to do is test the LEDs that they work, and for that I'm going to use the Ligum Dio, which is another Boldport Club project, and just plug it into USB, and it has a constant current driver and of 20 milliamps, and I can just put there are holes here and little slots here that you can just put through, or put holes, or use here. This bit is meant for surface mount components. This mirror bit. Okay, this one's fine. It's good to check that they work, because once you solder them, it would be difficult to, well, it would be annoying to take them out. Okay. Okay, so those are fine. Now the PCBs. So you get 3 lovely PCBs. Again, they are the same, and we're going to follow the instructions in order to see how to lay them out. So right here we have the top view. So I'm going to align it. The thing to notice is the in terms of sort of top bottom of the face, is that there's a side that has 2 rows and a side that has 1 row, and that's important to pay attention to. So we have that one here like that, and another one that is like this. And another one that is like that. So this is the bottom board, the middle board, and the top board. And again, following the instructions here, we need to flip this one over. And now we're going to solder the FETs, the N-channel transistors, which here just act like a switch, and we'll go through the simple circuitry at the end. Right. So you see here on the top left in the camera, you can see that there's a flat end to the transistor package, the TO92 package, and that helps us orient the FET according to how it's supposed to be connected. So top one, it's in the internal row. Okay. And the flat face is facing outwards. Okay, so that's the first one. The middle one, it's in the bottom, it's in the outer row, sorry, column, and the flat face is facing inwards. Okay. And then the bottom one, it's facing outwards on the outer column. Okay, so now we have the three circuit boards with the transistors attached, and we're going to start soldering. I'm going to turn on this fan. So they sort of stand on their on the package itself. There's another Boldport project spooled, the spool holder, and we're going to solder these transistors in place. Yeah. Even me, as someone who designed it, still get nervous about building this, because it's tricky to think about. I think I need this to go. Okay, so wait, no, I need to keep the order. This was the first one, sorry, the bottom one, the middle one, and now we're going to do the top one. Okay, so as we do, I'm going to do the domes right now, and of course cut these. We have to do this as we go, because when we start building or attaching things together, it'll be harder to get to. So when you're cutting these flush or cutting these pins at all, always shield with your hand, hold it, or just put your finger on top so it doesn't fly. But also be careful not to scratch the board as you're doing it. Alright, so I'm going to do the dome thing. Which means just applying a little bit of solder and letting go. And we have nice, smooth, non-IPC compliant solder joints. Okay, that's top one, bottom one. Now we look back at the order of the board just to make sure that we got it, we still have it correct. So the two rows at the bottom, this one like that, and this one, oh, just have to fix this. And this one is the top, top like that. Okay. Solder transistors, done. That was step number 1. Step number 2, solder LEDs on the top of the top board. Okay, so here. And now we see right here, oops, right here, I'm not sure why it's not focusing. Yeah. So you can see the long leg and the short leg, and we need to pay attention to that because there's no indication on the board. There's no square hole or square pad or something. They're all square, or there are square pads, but no no round pads like I normally do. Alright, so we take this one and we have the long leg facing the inside. We have another one, again the long leg facing the inside. Right. So what I would normally do, I would do just one leg. Here. And here. And then I'd heat up the leg again and push against the LED against the board to make sure that it's sitting flush. You can't do that when you solder both legs. So yeah, this one pulled, I was able to push a bit inwards. So yeah, so it's sitting flush. And okay. Okay, looks good. So now I'm gonna cut the legs. Again, I'm going to do the domes now, because later it's going to be difficult. Now, these pins are fairly close to each other, so you need to make sure that there are no shorts or bridges between the two pads. Okay, so that one's look good. I'm going to again verify that I have it correctly. Like that. Okay. Alright. Place female male standoff on bottom board. So this is female male standoff. And on bottom board. So that means that I do this, I screw in I actually forgot to bring a... No, it's secure enough. Let's see if I can... Yeah, no, it's fine. Okay. All right. Now, place resistors through bottom board. So I'm not really specifying which resistors because you can see that in the photos. So I'll just follow that. We have 220 ohm resistors, 6 of them, and 10K. Turn this off while I'm doing this. Okay, so we're looking at it. I'm looking at the picture from this side, and I'm seeing that I have 220 here. And a 10K next to it. Now I'm deciding now how I want the resistors to be placed. Of course, there's no polarity on resistors, but they do have those the value color bands, and I just want them to align throughout the board. So I'm gonna put it like that. So all right, and then we have 2 down here, the 220 and the 10K. Like that. Now I'm cheating a little bit. Don't want to mess this up. I'm looking. It's right here, so I'm looking at the one that is already built. But yeah. All right. So now we have that, and so place resistors through bottom board. Fit middle board onto resistors. I wrote resistor. Oh. Resistors, and place female standoff. Okay, so what we're going to do is take this board, which is supposed to be that way, and fit it through the corresponding holes. We'll fit the components through corresponding holes and through the middle hole here. And it said fit the female standoff. Okay. So now we have this. The resistors are not going to fall off, and we can place them in the middle. So for that, I use tweezers to place them in the middle, and put this here. put some solder on the leg. Yeah, that's in the middle. I'll hold it in place and remove the iron, because sometimes you'd remove the iron and it'll pull the component, and you don't want that. Well, you can always adjust it, but so put more solder. Okay, now I'll align it. Okay. Okay, hold it. Okay, so now these are in place. Okay, here I really need to adjust. Okay. Okay. Those are done. And now I sort of skip a stage. I can take these out. But I can also cut these already. They're not going to move. And I'll just solder them. Just make sure that you put enough solder. You can see it went to the other side. That means it's all, the hole is full. You got a good connection there. You don't want a lot to flow, but you just kind of want to see it. Again, you wouldn't use this kind of stuff in production. It's not IPC compliant, and IPC is a standard body for that recommends and tests all these techniques for reliability, and I came up with this. So it's you know, it's nice, and it feels nice, but and it looks nice, but it's not for production. Right, so now I'm doing the other side, right? I couldn't do it before because then the resistors would fall off. I'm just giving it a bit of an angle. Okay. Alright. That step is solder resistors in the middle between the bottom and middle boards, right? We've just done that. Repeat process for the middle and top boards. So here we have 4 resistors on each side, the remaining 4. Okay, so we have on the opposite side of these two, yeah, we have the 220, and we're putting it in the orientation that we chose. then 10K, another 10K, and I'll do 20. And the same here. 220, 10K, and 220. Okay. Now we take this one and make sure again that we're doing it correctly, that it is the two row side that is going facing us. Right. This is slightly more tricky. It's not so bad. There we are. Okay, so now we get the screw, put it in there. I don't have a screwdriver, but I can use this thing. Okay. Alright, so, oops. No, that's fine. Alright, so we now repeat the process of what we've done before. Okay. Okay. Right. I'm done with that. Let's click these. Maybe wait until they're cold. And again, I'm going to clip. And solder. Okay, I'll make these look nice. Okay, repeat process for middle. We've done that. Middle and top boards. Bend LEDs to length and solder them. Alright, so bending the LEDs, if we look at the completed board, you see that there's a 90-degree bend on the LEDs. So we're just going to do that sort of freehand using, I've got these. Actually, I'm going to try something. I'm going to do, in order to get them the exact length, the same length, I'll do two at a time. Just rent it. It's not crucial you get it perfect. You can also play with the height once you solder it together, solder it into place. Okay, actually I might need to bend them the other way. We'll see, because again, according to the infographic, I'm going to pay attention to the long leg and short leg and how to put that into the board. So I'm just going to stage this. Okay, this is long leg facing me. Alright. Yeah. So this one doesn't really fit any of them. It's okay, long leg facing me. Yep. Alright, so I need to bend it the other way. If I bend it the other way, yeah, alright. Now, needless to say, you don't want to bend them too often, too many times, because then they'll just break. But this looks to be okay. Right, so this is towards me. And how did I not get this right again? Huh, okay. Yeah. Still okay. Not sure what happened there. But it does. Okay, so we're gonna put this in place, and we're gonna do the same kind of not trick, but technique where we put solder on one leg. So now it's in place, and I'm going to heat up the joint and let it dry, let it cool at the exact place where you want it. So now I do the other side. All right, good. So that was that. Now let's do this one. Oh, didn't actually solder it. Sometimes all the solder goes into a blob on the iron. Okay, so we have that. I heat this up. Put it in the middle. A bit more. Done. Okay, so that's that. You know, yeah, so I made a mistake. I had the PCB in the wrong way, and therefore the LEDs were in the wrong place. So because we have, hold on, no, that still works. That still works. Okay, symmetrical. Okay, right. So we have the long leg facing outwards, which is correct. All right. No, it's fine. Don't need to do any desoldering. Okay, so it's symmetrical. That's good. Okay. Again, center it. Let it cool. Do the other leg. Okay, and now this one. Going to clip these now. Alright, now just make them beautiful. Again, the distance between, or in technical terms, the pitch between the pins is quite short. So when you do this, just make sure that there aren't any shorts. Okay, let this one be. Alright, we're almost there. So now let's make sure the orientation is correct. And now we're going to do the capacitor. So place and solder a capacitor. So we have this capacitor, and we need to put it on the side that is away from us. So you can see this pin, which is power, goes to this pin, which is ground. The other way, yeah. I mean, you could flip those. This is actually ground, and this is power. Right, so let's do it. In this case, I decided for assembly to put it at the end after sort of constructing it. And what you could do is just clip the lead. And again, we're looking at it from here, so it's this one to this one, the internal one, yeah, internal one, internal to internal, and do it like that. All right. Now, again, put it in the center. Adjust. And solder. Clip. And make beautiful. Okay. Don't like when things touch, so I'll just give it a little bit of a bump. So there's a bit of a distance, a bit of a gap between them. There's no real reason. It makes me feel better. Okay. Now, number 10, the longest. Through the inner 6-hole header, again, we're verifying that we're looking at it the correct way. The inner 6-hole header, just above the 8-hole header, okay. Insert wires in the middle 4 through the 3 boards. So with the kit, we get 5 of these wires, rigid wires. So 1, 2, 3, 4, and 5. So we're told put 4 in the middle, in the inner header in the middle. So we're doing just that. Okay, that's one. That's 2. That's 3. That's 4. right? The inner 4 of the inner 6 pin header that is above the 8 pin header. So we have an 8 pin header and a 6 pin header, and we're putting it through the 4 internal holes, and those go straight. Go straight through the 3 boards. There's no angles here. Alright, and what I do here, I'll just put these through to the edge. Just poking a little bit outside, and I'll solder them in. Solder them into place, I mean. Okay, now I'm going to clip these. And repeat. Okay. What's important now is to make sure that we solder the wires in through the middle board, because it might not be a good connection. What's important, no, both of them are important. It's all 4, yeah. Actually, sorry, no, all 4. Okay, just a little bit of solder to make a connection. Let me think. Just now got myself curious. These. This is ground, this is power, so it has to go through the 3 boards. But these, I think, I have to verify with it, they don't actually need to be connected to this board. But it doesn't matter. Okay, now that was the first part. The outer holes are connected only between the outer holes of the 6 header are connected only between the bottom and middle boards. So we have this last wire, and we're going to use that in order to do that connection. So putting it in the outermost hole, and I've already noticed that there was a little bit of solder in that hole, and that means that the wire doesn't go through. So what I'm going to do is I'm going to heat up that hole so it's clean the iron, so I'm not making the problem worse. Actually, adding a bit of solder is not going to make it worse, but as long as you keep it, I'm just pushing. It's a bit stubborn, even though there's already a connection. There we go. Okay, that's there. Let's solder it. Okay, clip. Okay, now I'm going to do the other one. Okay, so now I'm just going to make sure that the wires are not touching each other. We don't want to create shorts, and of course not touching the standoffs. So just move them, nudge them a little bit. There's quite a bit of distance. It's just more kind of aesthetic. You want the wires to be nicely aligned. Okay, so I think we're done with the optimistic side of this assembly. Now it's a time where we find out if it's working. She's always a bit, causes some anxiety. But oh yeah, all right. So we have a 10-pin header. We only need 8, so we're gonna cut 2 out. And then we have this 8 wide header here, and I'm not sure if it's visible, but the holes are staggered. That means that we can sort of loosely pressure fit the header in there without soldering, so we're going to try to do that. It's just enough for it not to fall and create a connection. It's not a terribly reliable connection. I mean if you wanted something to work constantly for 10 years, I would solder it in place. But in this case, you see, I can hold the board. It, you know, takes a bit to take it out. I might even need to use tweezers to take it out. Right, so we're connecting that. Now, for power, I'm going to put 5 volts in here. And I have this thing. It's just a USB connected to a 2-pin female header, and according to the sheet here, we have this. We're talking about the middle pins. The right one is ground and the left one is power. So we have 5 LEDs on. Alright, so one of the LEDs isn't working, and not sure why. Okay. Well, looking at it is not necessarily going to solve it, but oh, I know why. Yeah, I soldered the transistor in the wrong place. I soldered it in the inner column instead of the outer column, so I'm going to try and fix that. I have spares here, but I'm going to try to make it. So I'm heating up the 3 pins and just gently pulling the component out. Gonna try to help. Well, sometimes, like I said before, taking away solder is not necessarily the easiest way, but I'm going to try again, just pulling it out. Try it with this. using braid because getting the solder sucker in there is going to be complicated. Okay, that pin looks to be out. Okay. One of the things I like about these tweezers with the angle is that you can apply force against the board, a little bit of pressure. So in this case, I'm just going to apply a bit of pressure when I'm heating up this pin. Okay, looks a bit like a war zone in there. But no. Okay, I'll keep trying for a little bit. It's a good thing nobody's watching. Ay. Well, it happens. It happens particularly because, you know, I think I know what I'm doing, and then it's easy to not pay attention to things that are important. So it's just the way it is. Luckily, we're only playing here. And of course, none of you are going to make this mistake, because I made it for you. Okay. Okay. Oof, it's out. Looks like hell, but okay, let's see if I can salvage this thing. Thing is, it's easy for me to just take a spare one, but a lot of you guys at home are not going to have it. So yeah, it was a bad idea. Okay, so what I am going to do, or what I usually do if in these situations that I try before I commit to soldering this thing again, is to see that it's actually working and I haven't destroyed the component. So try to fit it in. Okay, it's not fully inside, but we'll see. Yeah. Okay. So now we need to check that the FET is indeed working, and yeah, something fell on the floor that I need, but get it. Okay. Right. So we'll have a look at the circuit in a second, but the idea is that if you connect any of these pins to ground, the corresponding LED will go low. So in this case, I'm just going to hook it onto this wire, onto this this wire, basically this this clip, and onto this wire, but it's just the same, this common ground of the circuit. So and then I'll touch this LED goes to ground, goes low. This LED is going low. This LED, this is the inner one, and the other inner one. And this one, and this one. Okay. I'm just going to solder quickly the problematic one, the sort of ones that I hacked in, so it doesn't cause more trouble again. Oops, just disconnect this. Okay. Oops. Yeah. All right. So here we are. It's working. Oh yeah, there are instructions here how to make it work. Insert header, soldering it is optional, and connect power and ground to the pins shown. Connecting ground to any of the other 6 pins turns the corresponding LED off. 3.3 to 5 volts works well, consuming up to about 80 milliamps. For higher voltages, you need to check that the supply is capable of supplying that. So if you're, for example, connecting your Arduino supply pin, you need to make sure that it can supply the current, because current supplies have a limit of how much current that they can source. And don't exceed 20 milliamps per LED. And make sure that the IOs on your microcontroller, if you're going to use a microcontroller, that they can tolerate the supply voltage. So 3.3 is pretty standard. A lot of microcontrollers can tolerate 5 volts. Above that, you will probably need a level shifter. So between the supply voltage and the IO voltage on these pins. Alright, so let's get to the circuit diagram here. I'm having trouble with the zoom today, and I'm not sure why. Okay, so here we are. I'm just going to hold it. We have the transistor, the 2 resistors, and the LED. And power is going to the other side of these resistors. So you know that for an LED we need a current limiting resistor. So because if we don't limit the current that goes through the LED, it will burn. And normally LEDs will have a 20 milliamp higher max current that they could tolerate for a long period of time. So you don't want to exceed that. So this is the current limiting, and it's sort of set for 5 volts. So if it's lower than 3.3 volts, 5 volts, you would start seeing the LED be a bit dimmer. Now that goes through the drain of this N-channel FET, and the gate is pulled high through this resistor. 10K is what's normally called a weak pull-up. It'll slowly pull this up to power, which means that the gate is on. That's why when we put power on, all LEDs are by default on instead of off. Is because this resistor pulls it high, pulls the gate high, and when the gate is high, this transistor, which is essentially a switch, is on, and it's connected. The source is connected with N-channel. The source and drain are reversed, so that's why this is the drain, this is the source. Is connected to ground, and therefore we have path for the current to flow, and the LED is on. And when the pin from your microcontroller, or what I put through this clip, when I connect it to ground, there's current flowing through here, and this is ground. This is grounded, and the switch is off, therefore the LED is off. That's all. Okay, I think that's it. So we've had ourselves a little bit of an adventure. Some unexpected mistakes, but you know, mistakes happen. I do make them, and we just need to be prepared and sort them out. It's always good to have spare components like the 2N7000, which is a general purpose MOSFET transistor, and in case it gets zapped by static, or you do what I did and placed it in the wrong place, it's a bit of a job to take it out and then make it work again, instead of just clipping out the pins soldering them out and putting in a new one. Okay, so this is going out on Monday to Boldport Club members, and if you want to get one of these, you need to sign up to the Boldport Club. You go to boldport.club and enter your payment details and your address, and you'll get one of these. And if you wanted the previous ones, which I admit were a bit easier, then they're at the shop. And you can, like I said, you can get a discount for those. That's it. I think I'm a bit exhausted now. All right, bye.